Algebra 2. Today is lesson 9.3, rational functions and their graphs. So a rational function is in the form of f of x equals p of x over q of x. Basically what that is saying, these are all different types of rational functions. Okay, it's when you have a function over a function. Those are your rational functions. So we have points of discontinuity. So when you have points of discontinuity, you have two different types. We have asymptotes and we have holes. So with the asymptotes, we found those yesterday. We found the vertical and horizontal. So we're going to do the same method when it comes to dealing with these problems. We're going to be finding our different types of asymptotes. And we're going to determine whether or not an equation has a hole. And I'll go over exactly what that means. So the first few problems that you'll be doing in your book deals with find any points of discontinuity. So that's what these three examples are going to be. These are going to be your very first few problems, the 2 through 8 even. That's going to be those first few problems. So asymptotes. That's what we're looking for. Those are points of discontinuity. That's where the graph. So when you have your graph, or you have your rational graph, let's say we just have a basic, notice we have some discontinuity. The graphs are not connected to each other. We got one branch here and one branch there. So there's discontinuity. And where those discontinuities lie, those are your asymptotes. Okay? Those are your points of discontinuity. So these ones here, for finding the asymptotes, all I'm going to do is find my vertical ones. Not gonna work with the horizontal ones on these. Find your vertical ones. So we're taking our denominator and we're setting it equal to 0. I can factor that, x plus 4, x minus 4, and that equals 0. So my points of discontinuity are plus or minus 4. That's all it's to it. Those are your points of discontinuity. Those are your two asymptotes where these graphs are not connected, where they've branched off and done different branches. So this one here, I'm going to do the same thing. Again, I'm not worried about the numerator, just that denominator. So I'm going to take that denominator and set it equal to 0. Subtract 3, so you got x squared equals negative 3. Root it, I've got x equals root negative 3. Remember what that is? I root 3. It's imaginary. Therefore, it does not have any points of discontinuity. So this one here, because that's an imaginary asymptote, there are no points of discontinuity. Okay? And that's only happens when you have your denominator getting you an imaginary number. This one here, always factor first. That's always key, because it's easier to do it when you're factoring. Factor first. Factors of 8, 4 and 2, plus, minus. So my 2 points of discontinuity is when x equals negative 4 and x equals 2. Those are going to be my 2 asymptotes, or my 2 points of discontinuity. So when you're doing those first few problems, the 2 through 8 even, that's all that it's asking for. All that it's asking for is for that denominator, setting it equal to 0 and solving for x. Okay, that's exactly what it's looking for. So when we get down to our later problems, or our next set of problems, I'll bring up this one before we do the horizontal asymptote there. So when we get to our next problems, again, these ones here, they want to know your points of discontinuity. So when I'm looking at problem number 13, notice it's factored out. So what I'm going to do, very first step, I want you to find your possible asymptotes. Okay, find your possible asymptotes. Well, I'm looking at the denominator. I have 2 possible vertical asymptotes at x equals 2 and x equals negative 1, right? Just set them both equal to 0. X equals 2, x equals negative 1. Well, there's something weird here, because I can simplify this function. I can simplify this function to x plus 3 all over x plus 1. So here's what's different now. This is what's kind of confusing. What is my actual vertical asymptote then? The negative 1. There is my actual vertical asymptote. But what about this guy right here? It is a point of discontinuity because if I were to set that denominator equal to 0, set it equal to 0, 2 would pop up. Or there's no way, like if I plug 2 in there, it equals 0. I can't have a 0 in that denominator. So what is this 2? That's a whole. So 3 would be the whole, which is at x equals 2. So if I want to find what the other point is when I'm dealing with where that whole is, I take this and I plug it into that equation. So I take 2 plus 3 all over 2 plus 1, which is 5/3. So at my point 2, 5/3, that is a whole. So let me go over this one more time because this is really, it is kind of something that's very confusing and it does perplex a lot of people. So I'm given my function. First thing I always state my possible asymptotes. So I stated my possible asymptotes. I have 2 vertical asymptotes at 2 and negative 1. But when I simplify that down, when I cross out that x minus 2, because I can cross cancel that, I am left with x plus 3 over x plus 1, which makes that my real vertical asymptote. And it takes my leftover point and turns it into a whole. Then I take that leftover point and I plug it in to that equation. So I'd have 2 plus 3 all over 2 plus 1, which is 5/3. Okay, so let's look at this one here, doing the same exact thing. This is like number 14 off of your homework. Okay, number 14 off your homework. First thing I'm going to do, factor it. So let's factor that. Let's do our difference of squares. X plus 2, x minus 2, all over x plus 2. So first thing I'm going to state, my asymptote, my vertical asymptote, would be at x equals negative 2, right? X equals negative 2, that denominator. So I'm looking here, I can simplify that. My second step, my simplify. That cancels. So I'm left with x minus 2. Well, there's no denominator anymore. Therefore, do we have any asymptotes? No. That makes this right here a whole. Plug that in there. So I would have the point negative 2 minus 2, negative 4. That's where my whole would be. And if I were to graph this, okay, I'm just going to graph this linear. I simplified it down. It's a linear function. We start down here at negative 2, up 1 over 1, up 1 over 1. Okay, again, not drawn to scale, to the best of my ability there. Oof. There's a hole at negative 2, negative 4. So in negative 2, negative 4, there is a hole in that graph. That is the point of discontinuity. There's no asymptotes. Why is there no asymptotes? That's a linear line. When I simplified that down, it became a linear line. Therefore, you wouldn't have asymptotes. It's not a rational function anymore. So that's why we had the hole. And when I simplify it down, I take that point and I plug it in for that, and that's how I got that negative 4. And that's how you find asymptotes and a hole if you have a hole. One thing when I took my pre-calculus class there for my master's program, the one problem that I missed that I just couldn't get time and time again was because I forgot the whole concept that there can be a hole in the graph, a break in the graph. And if you were to graph this function and open up your table on your graphing calculator, you would see at when x is negative 2, it doesn't exist. There will be a blank spot there on that calculator table because that is a point of discontinuity. Okay? So, final thing, horizontal asymptotes. And those aren't too bad. Those are what you're going to be doing at the very end of the problems. So, a horizontal asymptote, long division. And I know what you're thinking. I don't want to do long division. Trust me, this is very simple. So I'm going to take my x minus 1 divided by my negative 2x plus 6. Well, what would I multiply to x to get negative 2 there? Yeah, negative 2. Guess what your vertical asymptote is? Or not vertical, I'm sorry, excuse me. Guess what your horizontal asymptote is? There it is. Y equals negative 2. That's all it's to it. Do I have to go through the whole process of the long division? Absolutely not. Okay, not once I just find that term up there. So, that is rational functions and their graphs. I know this is going to be a pretty difficult lesson because sometimes it's hard to understand the concepts. But just go through it step by step. And on those final problems where we're talking about holes and all that good stuff, do it out in steps like I just did previous. It helps. One final thing, the graphing. So when I look at this one down here and I want to graph that, notice I brought out the graphing part of the board that I finally just realized I had, mind you. So I look at this graphing, or I look at this equation. My vertical asymptotes are at x equals negative 3 and x equals 4. Would I have any holes? Nothing cancels. Therefore, I would not have any holes. There would be no holes. Okay? None whatsoever, because nothing canceled up here, nothing simplified down to eliminate my asymptotes. So when I'm going to graph this, first thing I'm looking for, especially when you guys are graphing, is for you to do out your asymptotes. So we're going to come over here to negative 3. We're going to take my line, go straight down. There's an asymptote. X equals 4. 1, 2, 3, 4. So we're going to come down. Okay, so when you're graphing this, same thing as it was before. Notice that there's nothing out behind here. So more than likely my vertical asymptote going to be at 0. I could simplify that down and divide it. Notice if I were to divide this, this is like an x squared minus x minus 12. When I FOILed that out, there's no way I can take x squared minus x minus 12 and try to divide it into the x plus 2. Therefore, I know my vertical or my horizontal asymptote has to be at 0. So when I'm doing the branches of these, again, same thing as we did before, I'm going to connect my branch here. Okay, so I'm going to have a branch here. And then up above over on the other side, I'm going to have the other branch. Now, what's happening in between here? Something is happening in between. Okay, so when I am looking at this graph here, I'm going to deal with some sort of a cubic function that comes down. Now, when you guys are graphing these, what I'm looking for, and I know what a lot of colleges are looking for, your asymptotes and the asymptote lines. The stuff in between, the branches are easy. This is a little bit more complex. Use that technology. Use your graphing calculator. Okay? So when I'm grading it, or when you're taking any type of test, what we're looking for is that you have your asymptotes labeled. And that is today's lesson. Okay, so again, if you have any questions, you know how to get a hold of me. Have a good rest of the day, guys.